Hi all, this is Harini. Welcome back to the YouTube channel Code with Harini. Today we are going to solve July Day 9 LeetCode challenge, which is reschedule meetings for maximum free time. So now just take a look into the question. So they'll be giving you an integer event time that denotes the duration of an event. So which means the event time 10 means it will start from 0 to the time 10. So also they'll be giving you a two integers array start time and end time, each of length of n. So okay, so they represent the start and end of time n non-overlapping meetings. So it will not overlap. So also in where the ith meeting occurs at during that time, start time of I and end time. So if this is I0, so that event meeting of 0 will be at starts at 0 and ends at 2. So that's how they have given us the input. So we can reschedule at most k meetings. K meetings means you can start reschedule 0 to the max. You can reschedule k meetings, but we have to maintain the same duration, but we have to maximize the longest continuous period of free time. So here if you see, the maximum free time will be 1, right? Because in between only one. So what they are telling, you can reschedule at most k 1 meeting, so that the longest duration, continuous duration will be maximum. So now if you reschedule this 1 to 2 to 2 to 3 or 0 to 1, our longest maximum free time will be 2, right? So that's what we have to return as the output. So also the relative order of the overall meeting should stay same. So you should not take 3, 4, 5 and put it in front if you have the freedom, nothing like that. So the order should be same, and we have to return the maximum amount of free time after rearranging the k at most k meetings. I hope now you guys have understood. So let's take a look at this example. Now I have already explained this. Either we can move at most k equals to 1, either we can move this to here or this to here, so that we will have the maximum length, maximum free time for the free maximum free periods will be 2. So the same here, event time equals to 10, and you can you have 3 meetings, but you can change at most 1. So now if you change this to the last here, or this to 1 meeting ahead, okay, so 1 2 3, now 3 minus 9 will be 6. Earlier 4 minus 9 was 5. So like this uh, we'll be rearranging the meetings to have the maximum even. So this 5, and they given 5 and k equals to 2, we can rearrange 2 meetings. But if you see, start time 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So all this were occupied already. It was already continuous. There is no even there is no free time left. So there is no possibility to rearrange as well. So like this, we have to rearrange, and we have to figure out how this works. So let's look into the, let me explain how this works first. So now take a look at this example. So already I have chosen an example. So that is event time equals to 15, k equals to, I can rearrange, and start time, these are the start times, these are the end times. So now this is how that event looks, whatever the green indication, that's all. So now to get the maximum free time, if you see, 6 minus 13 is 13 minus 6, sorry, we can rearrange for 2 meetings, right? Maybe if I would have rearranged 2 here, so if I would have rearranged 2 here, and this, not this, and this 2 here, so what would be still maximum would be between any not between any whatever the maximum free time that is left. So if you would have changed this meeting to here, and here it would have ended at 3, right? 3 to 5 is 2. So this is not maximum anyways. So again it will come here. 6 minus 14 is 8. 6 minus 14 is 8. So this is not maximum. Still we can choose this to here. The whatever the red color I have marked, right? If we would have, instead of this event, if we would have moved this, right, 5 to 4, so 5, it would have reached to 5, and this end point is 15, sorry 14. The start of this event is start, this end and this start we should always consider, right? So that only we can have the free period as 9. So this is the answer. So the output for this is 9. How we are going to achieve this? Output is 9. So by this, if you take a look, they also suggested us one thing, like whatever the events should not be rearranged. If this is at third position, at fourth position, even after you rearrange, that should be in the third position only. It can't be rearranged here and there. Okay, so they have given k equals to 2. So to the max we can rearrange k events, any k meetings, right? So if you see, if you are clubbing together any two meetings and if you move those to right and left, we will get the maximum, right? If you change something else, and if you change at some at one, not at the consecutive, if you change adjacent two elements and move this to right and move this to left, or move together even, okay, even if you move together, whatever the space left over, it will be the same. So what we are going to do for this, so we will be clubbing some k together, and we will be subtracting whatever in the left, whatever in the right, as well as the duration of this events. Okay, for example, let's assume, so this is the total. Now we are going to take this two events, that's what we decided, right? This two events. So if you take whatever from, what we are going to do is, what is this, right? So we are going to ignore all this. Sorry, we are going to take this two events. This is what in consideration in our mind. So two events we are going to take. What is the left to this is 4. So to the max you can move this event to 4. So that's what. So right, we are taking it as a 4 to this. Sorry, left. My bad. So left equals to 4. Right equals to what? It's right. This right is 14. Correct? Sorry, not 14. Because after this there was no event left, right? So you can take the event end time. So if you would have taken this right, then till we can take only whatever the left between maximum free time is maximum continuous free time. It's not like all the free times. Okay, so you have to take if you are taking, but now we are going to club this together, so we have to consider this right and this left. So here if you see, this left has some other events already, so you can't club all these free times together, so that's why we are taking 4. After this, if you see, we don't have any event, so we can take the end time of the event time. Okay, so that's what. So right equals to 15. Okay, now what all the periods that it got occupied already, this is 1 and this is 1. So we will be subtracting the total periods that was 2. So 15 minus 4 minus 2. which is 9. So we got our answer. So maybe if you want to take a look, we can club other two together. Let's see this two together. So what is the left? So this is our maximum, right? Now I'll be going through the other things. So this, if you take this two together, okay, this left has no even meeting, so left is 0. After this, if you see this two events, right, so this right is 5. So right is 5. Total period is 0 1. So in this 1 plus 2 3. So what we will be doing, right minus left minus 3 equals to 2. We got only 2 free times in this. Even you can see that in our visually as well, 1 2. So if you adjust these two meetings club together to this club, if you club together, right, you can maximum you will get only this, okay, as a free time. It's not maximum, but I'm just telling you can't rearrange this as well, right? Since you have rearranged this to meetings, we can't rearrange this. So again what we will be getting, we will be getting 8 as a maximum if you are rearrange this. So that's what we are trying to understand. So we have to optimally rearrange some event to get the maximum. Yeah, I hope this you guys would have understood how this works. Now let's look into the pseudocode. Okay, so now let's remove this. Now let me write the pseudocode. So we wanted since we are going to club together everything, right? So we know already the period of each. If you just subtract the end time and minus start time, we will be getting the total period. So to get this period, we let's assume you want this period here. What if we total all this? What will be the total? 1 3 plus 1 4. 4 minus 1 will be we will be getting this. So what we are going to do, we'll be adding on this whatever the period exists, will be keep on whatever the period exists, we'll keep on adding to that. So whenever I is going the k, so we will be subtracting I minus k so that we will have the corresponding k number of totals clubbed together. That's what our idea is. Let's look into this Sudoku. So def max free time we will be, so what we will be getting, event time, start time, end time, and k. These are what we will be going to get. So length will be same for start and end, so we will be taking it as a end. So now we are going to have a total which stores at each event what are the total number of period. Um, so at each event crosses, what is the total number of period that got occupied, so that we can just do right minus left minus total of I minus total of I minus k, so that we'll be getting right minus left is nothing but how many leftover we will be getting. In that, if you subtract the occupied periods, you will be getting this maximum length. This occupied period, now we are calculating this total as a whole, right? So we'll be subtracting this total. That's what we are going to do. That's how the code itself, that, sorry. Okay, now, yeah, now this is our total. So what we are going to do, sorry, for I in range. So for I in range n, we will be keep on adding the total. So here let's have n plus 1. So what we will be doing, we keep on having, so here total of I plus what we'll be doing, sorry, n time minus n time of I minus start time of I is our answer. I hope this you guys understood. Next, so now what we'll be doing for I in range, we'll be clubbing together everything. So k minus 1 comma n. Why this is k minus 1 comma n? Because we are going to club all the adjacent k's together, right? So like this we are going to club. So for the first, how many k's, for example, let's have k equals to 3 means for this, but I should start from 2, right? So for the first group, will be having the index of 2. 2 will be having till n, so that this is 2. For 3 again we will be, so this 3 we have clubbed already. Next we have to club another 3. So that's how the thing. That's why we are going with k minus 1. So we have decided already we are going to club the first 3 together. So what is the third index? From there we'll start. So if it, we are just starting at the end, so next we will be going here, which means we are taking this 3. Okay, I hope that makes sense why we are starting with k minus 1. So now we are taking the right equals to even time. If you, I hope so, right equals to even time if there is, if I equals to n minus 1, which means we have reached the last event. After this what will be, there is no more period meetings where this, so you can take event time. So that is your end. So that's what kind of, if I reaches the last, else we will be taking in time of next event. So that's how. So this is, if you are taking this 3, what is your end time right value? This, right? Sorry, end time, not start time of next, because this is the start time, right? So that's I start. Okay, so the same. So left equals to sorry, what will be left to the max, we will take 0 if I equal to k minus 1, because if you are going to club this together, okay, we will be subtracting this period. Okay, so what are these together, you are thinking as a 1. So if you are starting it this, so you are thinking it as a 1, what will be our left this. So if you are clubbing this 3 together, what will be our start? I minus a start time equal, so start time of, we have to subtract in time of, this is what our I currently will be, I minus k. So these 3 events club together, so like this. So this in time will be our left. Okay, so I hope this, if you're, I'm just making you guys understand again how come this works. If we are clubbing this 3 together, our formula of finding out max free time is max free time comma right minus left minus total of I plus 1 minus total of I minus k plus 1. Okay, this is what our, so now this total will already have all our collective period sum as we discussed here, right? Collective period sum it will hold. So now if you assume this is our first group, so if I equal to k minus 1 means obviously this will be our first k adjacent. So the left will be, we'll be taking it as a 0 because no more period exists before. The same if this was the n minus 1, obviously event time will be the right. There was no period exist on the right, no more meetings exist on the right. So that's what. So here if you see I left it some I equals to k minus 1, we'll be taking 0, else r, sorry again I'm again start now, n time of I minus n time of I minus k, because will be r I will be here, we are going to club this 3 together, so I minus k, this n time we will be taking. So that's what, when I equals to k, if not I equals to k minus 1. For example, in this example I am telling, if you have so many periods as well, the same way what we will be going to club adjacent k together, so we'll be doing either I minus k. Why we are doing I plus 1? Because already it will be having the k values together, so I plus 1 only will be having the right is always at so I will be always at having the last index of uh, 3 events. For example, here k equals to 2 means, so we'll be rearranging 2 events. So I will be always at the last. So I plus 1 will give you the next period start. So, but since it's at the last, so you have to get previous end time means left value means you have to go end time of I minus k, right? Because I is currently present at the a group of k last. That's why. So also here right minus left, total of I minus 1 I. So if you see, let's have this total. So total will be, this has 3 events, right? So 4, 0, 1, 2, 3. First will be 0 for the first for this first event it will be 1, for the second event it will be here if you see 2 plus 1 3, next 3 plus 1 this is 4, next okay obviously then it is 4, so 4 plus 1 will be 5. So to get, if you are clubbing this 3 together, you know if you're whatever I minus k plus 1 is, you just subtract that. So again if you're clubbing this 3, if you're clubbing this 3 together, you should subtract this, right, for from the total period. So because it is a cumulative addition of whatever the period exists. So 5 if you subtract, for example let's take, we are going to club, let's we are going to club this 2 together, okay, 5, 6, 14 and 5. So what will be our I'm just showing explaining you only this example. So what will be our right for this example, what is the right event time? So because it reaches n minus 1, I will be here, right? So let's assume I equals to 4, sorry I equals to 3, okay, right equals to I equals to n minus 1. So what will be our event time? Because currently I is here, let's assume. So not assume, that's what it is. So now I equals to here. After this there is no period, so we are taking right equals to 15. Now if you come to the left part, now what is left to this? We are going to club this two events together. So left part is after I minus k, whatever is, that is your left. So which means 4. End time of this event is 4. So left equals to 4. Now 15 minus 4 is correct. No? Because we have to subtract this two periods, right? 15 minus 4 won't be correct because this two periods was not a free time. We are going to club either here or here, that doesn't matter. So what we have to do, we have to subtract this period. So if you have to subtract this two periods, here if you take this total, instead of navigating everything and subtracting this, we have already stored it into a array. So what we will be doing, right minus left of, then here it's not zero based index, here it starts at 4, right? So that's what total plus 1, you are going to minus total of I plus 1, because here I is 3, those here it starts from 1 based index, that's why we are doing I plus 1 minus. So this I plus 1 holds all the periods together, but we have to subtract I minus k. Okay, we are going to subtract this periods that got accumulated till now. So what that is, total of I minus k plus 1, right? So that's what the formula lies here. So minus 5 minus 3. So 15 minus 4 minus 5 minus 3 is 2. So only 5 minus 3 will give you 2, right? So minus 6. 15 minus 4 minus 2 is 9. So this is our resultant. Like this, I will start first this here, then I will go here, then it will compute this 2, then I will go here, then it will compute this 2. So I already told why we need to compute adjacent, because the order should not get changed. So we can take to the max, if you take adjacent meetings together, the space will have more, that's what, we will have more free time. So what is the time complexity and space complexity for this? Time complexity is order of n, right? Because basically we are traversing 2 times, which is order of 2n, typically order of. So the space complexity, if you look, order of n, obviously, because we are storing this total. But if you look into this, we can avoid the space complexity. How? Let's take a look at that. So if you see, at any point we need one, when you're traversing from k equals to 2, k equals to 1, for example, if k equals to 1, so we at that point we need only this, not as a total. So when you're adding another at any part, will traverse from, instead of k minus 1 to n, let's traverse from I to 1 to n. Okay, so optimized approach, let's look into optimized approach. So the same, everything will be similar. Let n equals to length of start time, total we'll be ignoring. So let's, for I in range n, what I'm going to do is, instead we'll be adding the total, we'll have a total variable instead of which is always computing, right? Even if you see here, it's always adding up the previous. So let's have it as a variable even. So we'll be keep on adding in time of I minus start time of I. So this will have a total. When we'll be subtracting this, when it exits the k minus I minus k minus 1, that will always have it in the start time and end time, right? So when if our I exits uh, k minus 1, first we'll be computing for k. It starts with k minus 1. When it is going greater than or equal to k minus 1, we have to subtract our total. We have to subtract our total like that only, because the loop starts here and we'll be calculating right and left. Till then we'll be keep on adding the total. Okay, so then the same thing will be now. We have done that. Now the left equals to 0 when until if I less than or equals to k minus 1. Here the loop starts at k minus 1, so here the loop starts at k minus 1, so if k minus 1, so now whatever until the until we are taking the k, whatever the less what it is, we'll be taking it as a left. Will be whatever the ith is going until I reaches our k minus 1, we'll be taking our left as a 0. That's what we are updating the condition left. Then let me zoom a little bit. Else what are the same. Left will else what in time of I minus k. As previous, the same, the right equals to 0. Sorry, the right equals to even time. If this won't change. Else start time of I plus 1. So now when we'll be updating the total, so max free time is the same, we'll be computing. Here we won't minus because the total itself has only, here we won't minus this I plus 1 and all this, because the total itself has only k period. What are the k period values only the total already has. So we just do right minus left minus total. That's it. Now when we'll be updating the total, if I greater than or equals to k minus 1. Okay, now for this k minus 1 we would have computed. Okay, so now I will be going for the next loop of k, which is, for that you should have given the updated value of total, right? So that's why we are updating it at k minus 1. So now what we are going to do, we are going to subtract, we are going to add, I'll show you here. Now till I ran till the k minus 1, the total wouldn't have updated. Now for the next iteration I'll be going to this, so my total should have subtracted this, even should have got separated, so that I will be adding at here in time of. So that's why we are updating the total at I minus 1. So now when you are updating, what we will be doing, we are doing subtraction or equals to in time of I minus k plus 1, the same whatever we have done here, I minus k plus 1 minus start time of I minus k plus 1, so that we have avoided the space complexity and only the time complexity equals to order of n. Hope this makes sense. I have just given the exact, if you just understood this, this is the exact solution that I have given in the solution as well. Maybe I just show you guys. So if you see the total I k minus 1 event time, I equals to n minus 1, else start time plus 1. So the same pseudocode here we have just updated, and we are returning the max free time. Yeah, I hope you guys would have understood. Yeah, let me know in the comments whether you guys need any more explanation for anything, I hope you guys would have understood and try to solve it on your own. I'll also post a GitHub link for all other languages, solution in all other languages. Maybe you can just go on verify if you while you are solving if you are stuck at any point. Thanks for watching. If you like my video, please do like, share and subscribe. Thank you once again. Bye.